In this video, I would like to introduce the concept of the scope of a quantifier and two other related concepts called bound and free variable occurrences. Of course, all of those has something to do with quantifiers. In this example here, we use a universal quantifier at the very beginning, which binds a variable x. And you can see that there are two other occurrences of x in the formula. So the question is, which ones are bound and which ones are free? First of all, let me show which part of the formula is the scope of the quantifier. Well, the scope of a quantifier is the subformula which immediately follows the quantifier. In this case, p of x is the scope of that quantifier. The remaining part of the formula is not inside the scope. The occurrence inside the scope is now bound by the quantifier. So this is what we call a bound variable occurrence. On the other hand, the other occurrence of x is not bound. It's outside of the scope of that quantifier. Therefore, this is called a free variable occurrence. Some logicians use this arrow notation for denoting free variable occurrences. Of course, you can anytime extend the scope of a quantifier by introducing extra pairs of parentheses. Like in this case, I just extended the scope of this quantifier. And by doing so, I made all the occurrences of x bound. Let's see another example with more than one quantifier. So let me just use two quantifiers which share their scope. So now this is the scope of the inner quantifier, basically. What is important now that each and every variable occurrence is bound because of those two quantifiers, and there is no non-bound or free occurrence of any variable in this formula. Of course, in some formulas, quantifiers can be all around in a way that their scopes do not overlap, like in this case. Now the first scope is p of x, the second scope of q of x and y. And if we draw the boundness relationships like that, we can immediately see that there exists one free variable occurrence of x here, because this is not part of the scope of the quantifier that binds x. Of course, also in this case, we can extend the scope of any of those quantifiers. Let me just extend the scope of the first quantifier to the rest of the formula. So in this case, of course, each and every occurrence is going to be bound.